Hello friend, welcome you all in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about electron arrangement and ion charge. This is important for beginner in chemistry. We know that group 1A metals form ions with plus 1 charge. Group 2A metals form ions with plus 2 charge. Group 7A nonmetals form ions with minus 1 charge. Group 6A nonmetal form ions with minus 2 charge. Group 8A nonmetals do not form ions. In fact, they are extremely unreactive. So, representative metals form cations by losing enough electrons to get the same electron configuration as the previous noble gas. Nonmetals forms anions by gaining enough electrons to get the same electrons configuration as the next noble gas. Look at here. Atom sodium, it loses electrons, so it will go near to neon electronic configuration. So this is the 1 electrons. If it lose, then sodium plus, and it become the neon. Magnesium, it will lose 2 electrons, then it become neon. Aluminium, it loses 3 electrons, then become neon. Oxygen, it takes 2 electrons, then become neon. Fluorine, it takes 1 electron, then become neon. So representative metals form cations by losing enough electrons to get the same electron configuration as the previous noble gas. Nonmetals form anion by gaining enough electrons to get the same electrons configurations as the next noble gases. So sodium, magnesium, aluminum, oxygen and fluorine. Atoms electronic configuration 3s1, 3s2, 3s2 for 3p1, 2s2 2p4, 2s2 2p5. Ions, it lose 1 electrons, it lose 2 electrons, it lose 3 electrons, it take 2 electrons, it take 1 electrons, and their configuration become neon, 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 neon. So electron arrangement and ionic bonding. Representative metals lose their valence electron to form cation. Nonmetals gain electrons, so their valence shell has the same electron arrangement as the next noble gas. They have to be enough electrons from the metals atom to supply the needed electrons for the nonmetals. Allows us to predict the formulas of ionic compound. In polyatomic ions, the atom in the ions are connected with the covalent bond. The ions are attracted to positively charged ions to form an ionic compound. So what is the properties of ionic compound? All solid at room temperature, melting point greater than 300 degrees Celsius. Liquid state conduct electricity, solid state does not. Liquid is equal to molten. Brittle and hard, often soluble in water, and when dissolved, the solution becomes an elliptical conductor. When ionic compound containing polyatomic ion dissolve, the covalent bonds holding the polyatomic ion do not break. The ions stays together even though it separates from the other ions, all strong electrolytes. Bonding and structure of ionic compound. Crystal lattice, geometric pattern determined by the size and charge of the ions. Anions larger than cations, almost always. Anion larger than parent atom. Anion larger than parent atom. Remember it. This is very important for competitive exam. Cation is smaller than parent atom. I repeat, anion larger than parent atom. Anion generally considered hard, sphere packed as efficiently as possible, with the cation occupy the holes in the packing. I repeat, anions generally considered hard spheres packed as efficiently as possible, with the cations occupy the holes in the packing. Arrangement insert in each cation being surrounded by as many anions as will fit, and vice versa. maximizes attractions between ions. So friends, Lewis symbols of atoms in ion, also known as electron dot symbol. Use symbol of element to represent nucleus and inner electrons. Use dot around the symbol to represent valence electrons. Put one electrons on each side first and then pair. Elements in the same group have the same Lewis symbol because they have the same number of valence electrons. Cations have Lewis symbols without valence electron. Anions have Lewis symbol with 8 electrons valence share. Now you see lithium 1 barely